I'm Principal Sheep. Welcome back to our classroom. Today, I'll be teaching about the Reactivity Series, Redox, and Rusting. What is the Reactivity Series? It's a list of metals arranged in order of their reactivity. The most reactive metal is at the top, and the least reactive is at the bottom. This is the Reactivity Series. The first 4 react with water, and the first 8 react with acid. The last 3 don't react much, and gold, the last one, doesn't react at all. Copper and silver need a little bit of help to react with some things, but not much. This helps predict whether a metal will displace another metal from its compounds when it is mixed. In displacement reactions, a more reactive metal takes the place of a less reactive metal within a compound. This typically occurs when a more reactive metal is added to a solution containing a salt of a less reactive metal. The more reactive metal releases electrons and becomes a positive ion, while the less reactive metal's ions gain electrons and become the solid version of that metal. For example, if zinc is added to a solution of copper sulfate, the zinc will replace the copper, forming zinc sulfate and solid copper. This happens because zinc is more reactive than copper. Why does this happen? Well, more reactive metals lose electrons way easier to form positive ions. These ions then attract negative ions present in the solution, resulting in the formation of a new compound. This electron transfer is the driving force behind displacement reactions. Redox reactions, short for Reduction-Oxidation reactions, involve the transfer of electrons between chemical species. These reactions are fundamental to many chemical processes. Oxidation state, also known as oxidation number, represents the hypothetical charge of an atom in a compound, assuming that all bonds are ionic. A change in oxidation state indicates that a redox reaction has occurred. Specifically, an increase in oxidation state signifies oxidation, while a decrease signifies reduction. Metals have a tendency to lose electrons during chemical reactions, a process known as oxidation. When a metal atom loses electrons, its oxidation state increases, becoming a positive ion. This process is very common for metals due to their electronic configuration. For example, magnesium reacting with oxygen results in magnesium losing electrons and its oxidation state changing from 0 to +2. Conversely, metal ions can gain electrons, a process known as reduction, to form the elemental metal. This gain of electrons decreases the oxidation state of the metal ion. This process often occurs during the extraction of metal from their ores. For instance, in the extraction of iron in a blast furnace, iron ions gain electrons that are reduced to form metallic iron. Displacement reactions are a type of redox reaction. In these reactions, the more reactive metal undergoes oxidation, losing electrons, while the less reactive metal's ions undergo reduction, gaining electrons. For example, in the reaction between zinc and copper sulfate, zinc is oxidized and copper ions are reduced. So, to put it simply, oxidation is when you gain oxygen atoms and lose electrons. Reduction is when you lose oxygen atoms and gain electrons. Now, I'll give you a few questions to test your understanding. Will magnesium displace zinc from a solution of zinc nitrate? Explain your answer. Yes, magnesium will displace zinc because magnesium is higher in the reactivity series than zinc. Magnesium will lose electrons and form magnesium ions, while zinc ions will gain electrons and form zinc metal. Number 2. Identify the oxidation and reductions half reactions in the following equation. Mg is a solid plus 2HCl, which is aqueous, is MgCl2 aqueous plus H2 gas. The answer is the oxidation is the magnesium, because magnesium is the one that loses the electrons. Reduction is the hydrogen ions, because they are the ones gaining the electrons. Number 3. A piece of iron is placed in a solution of copper 3 sulfate. What will you observe? Write a balanced chemical equation for any reaction that will occur. When a piece of iron is placed in a copper 2 sulfate solution, a reddish-brown solid, which is copper, will form on the iron. Also, the blue color of the copper 2 sulfate solution will fade as copper ions are removed from the solution. Now, I'll give you a bunch of rapid-fire example questions. Which metal in the reactivity series is most likely to react vigorously with dilute acids? What is the oxidation state of sulfur in SO42 negative? Explain why gold does not readily react with other substances. Write a balanced ionic equation for the reaction between zinc and silver nitride solution. In the reaction, CuO is a solid plus Mg, which is also a solid, becomes Cu, which is still a solid, plus MgO, still a solid. Identify which substance is oxidized and which is reduced. The answers are potassium or sodium, plus 6. Gold is very low in the reactivity series, so it does not readily lose electrons. The answer to number 4 is Zn, which is a solid, plus 2Ag, positive, is aqueous, is Zn2, positive, which is aqueous, plus 2Ag, which is a solid. And the final answer is magnesium is oxidized, copper 2's oxide is reduced. The key takeaways from this is that the reactivity series is a valuable tool for predicting metal displacement reactions. More reactive metals lose electrons more easily, a process called oxidation, while less reactive metal ions gain electrons, which is reduction. Redox reactions involve the transfer of electrons, and understanding oxidation states helps identify these oxidation and reduction processes. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.